Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening. So we're just about to start a new chapter, data handling. Have you all taken up the two tests which I had scheduled?
Ma'am, this is Kirtana, ma'am. I finished the 2 tests.
Okay. I just ended the 2 exams today, and I hope you were able to see the solutions. So children, I'm sure you are familiar with the term pictograph.
Yes, ma'am.
Yes, ma'am.
Yeah. Now I want you to take a screenshot of this and go through this by yourself later. Take a screenshot. Please go through this. This one also.
Taken, ma'am.
Yeah, this one also, children.
Taken, ma'am.
Please make sure that you read through all this by tomorrow. Otherwise, you'll forget. Yeah, this is the third slide. Take a screenshot. Fourth one.
Ma'am, this one also we need to take screenshot, ma'am.
Yeah.
Okay, ma'am. Ma'am, just going through is enough or we have to write in a notebook, ma'am?
It'll be good if you can recall all this. Then fine. But it'll be good if you can do all this in your notebook.
Okay, ma'am.
Yeah. Yeah. We'll come again from the beginning. This is the first one. 2, 3, 4, 5, 6, 7,
Ma'am, I have a doubt in this one, ma'am.
yeah, ask me.
Ma'am, in the table they have given 75%, 61% and everything, no ma'am?
Yeah.
It's like we should write the bar x and y axis, and y axis we need to write the numbers and just put it as 75%, no ma'am?
Correct. Yeah. 75 represents 75% there.
Yeah, ma'am. I just had a doubt as it was a number and percentage.
Yeah, correct. 75 there represents 75%.
Okay, ma'am.
Okay. Yeah, so till here. Okay, so now when you make these graphs, what you observe here is that these numbers are multiples of 500. These numbers are multiples of 500. They're also multiples of 100. They're multiples of 10. They're multiples of 5, 50. How do you choose a scale? How do you choose the scale here? So the bars must not be very tall, nor should they be very short. So choosing an appropriate scale is very important. Along the x-axis, I have nothing to say. Along the x-axis, because they're just going to, on the x-axis, you're just going to show up these months, July, August, September, October, November, and December. And you know that the bars must be equally spaced. When you make a bar graph, the bars will not stick to each other. And the appropriate, see now the question is draw an appropriate graph. For a table like this, the appropriate graph is the bar graph. I'll tell you why a little later. So each one, so there'll be bars representing the different months. So there, this bar represents July, this one represents August, September, October, November, and December. You can see that the bars are equally spaced. So from the origin to the first bar, there's this gap. Maintain the same gap or the same space between the bars everywhere. Now 1000, 1500, these are the numbers which must be shown along the y-axis or the vertical line. So see, just imagine you mark off in hundreds. You say 100, 200, 300, 400, 500, 600. Imagine going up to 2500. 100, 200, 300, 400, 500, 600, 700. So 2500, it's very far. And that means that bar which represents 2500 is going to be very tall. It shouldn't be so. So like that, when you and you now supposing you mark 1000, 2000. Supposing you mark 1000, 2000, 3000. Then the bars will be too small everywhere. So like that, you consider the different options available and you have to decide with something which will be suitable for the values given here. So the scale here is 1 centimeter is equal to 500 watches. 500 watches. So see here 0, 500, 1000, 1500, 2000, 2500. And the bar for July will be 1000 units tall. Because it represents 1000. Yes, somebody wants to ask something?
Yes, ma'am. In which note we have to do all these sums in last year's graph note?
Yeah. If you have graph sheets with you, do it in the graph sheets and stick it in your tuition notebook. If you have graph sheets, I'm saying, you can just
Yes.
do it in the graph sheet and stick it in your tuition notebook. You can stick it in the book.
Yes, ma'am.
Just cut the graph paper to whatever extent you have used it, cut it and stick it in your book. Or else you can, if possible, buy, or if you have an old graph notebook which has some pages still left in it, you can use the same thing.
Yes, ma'am.
Yeah, you can use an old one if you have.
Yes, ma'am.
Yes, children, I don't have anything much to say on this. Please look at the table and the solution, the graph, and ask me your questions. No questions?
No, ma'am.
Look at the numbers here: 40, 45, 55, 25, 15, 35. So you can see the scale. We jump in fives, 0, along the vertical line. You can see along the vertical line, we mark off 5, 10, 15, 20, 25, 30, 35, 40, 45. The highest value we have is 55. We just show one number extra after that. 55 is the highest value. It's enough. 55 is sufficient. We just mark 60. You can even mark 65 and 70. Just show one value after 55, that's all. So that's about the values on the y-axis or the vertical line. Now you can see that each of the schools, for each of the schools, we have two different things: walking, cycling. Probably some children prefer walking to school. They live close, they live in the neighborhood, so they prefer walking to school. Some children prefer cycling to school. So for school A, you will have to show 2 bars representing walking and cycling. School B, you will have to show 2 bars representing walking and cycling. Similarly, for school C, you will have to show 2 bars representing walking and cycling. You can see that the bars of a particular school stick together. Note that the 2 bars of a particular school stick together. There is no gap between them. School A, walking, cycling, the bars stick together. School B, walking, cycling, the bars stick together. And you can see the same for school C. Are you all getting me?
Yes, ma'am.
Okay. And you'll have to differentiate the bars. How do we differentiate? See here, the bar that represents walking, they've just crossed out like this, used lines, you know, I can say slanting lines. And this one is probably shaded. If you're allowed to use color pencils or sketch pens, you can use different colors. You can color the cycling, okay, the walking bars in blue and say the cycling bars in yellow. The bars can be differentiated using colors. Or, you know, some lines like this, you can show grains on this one. If you don't shade, you can just show some dots, grains. Okay. So that should be mentioned. Rectangles with this one represents walking, and the rectangles which are grained like this represent cycling. You can alternatively use a blue color here and a yellow color here, or two different colors. Or you can color one and just leave the other one like that. Color only one of it, leave the other one like that. But whatever it is, you should mention that here. If you have colored one in blue, so a small square or a small rectangle, color it in blue and say walking. The other one, if you've just left it like that, just show a rectangle like this or a square like this. It's empty, so leave it empty and say cycling. Please go through the graph and any further clarifications. Take your time, children. I'll give you some time. Watch all the details. You can see your schools along the horizontal line are the schools, and along the vertical line are the number of children. Spacing, the two bars of school A, they stick together. Then the same spacing which we gave here, the same spacing. Then school B, same spacing, then school C. Can I move on, children?
Yes, ma'am.
So here you can see have a look at the numbers first. See the range of the numbers. Which is the smallest value here?
Ma'am.
30, yeah? Okay, and the largest value?
78, ma'am.
78. Okay, so the bar of least height is the one which represents 30%, and the bar of maximum height is the one which represents 78%. There is nothing smaller than 30%. There's nothing more than 78. Then you have all kinds of numbers, 75, 61, 54, 47. So you can use a scale of 10. You can mark off 10, 20, 30, 40, 50, 60, 70, 80. That's fine. You can skip in tens, skip count in tens along the vertical line. You can say 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. 80 is sufficient. Let's discuss what is done here. So the scale here is every 1 centimeter. See, you know that we work with a centimeter graph. The graph which we use is a centimeter graph. Each square, these squares are of side 1 centimeter. It's a centimeter graph. So 1 centimeter is equal to 5%. The scale is 1 centimeter. Why 1 centimeter? It's a centimeter graph. Every 1 centimeter is equal to 5%. That means you're jumping in fives here. 5, 10, 15, 20, 25, 30, so on till 80, because 78 is the highest value. So we go up to 80. You can also show 85. No harm in that. 80 is sufficient, just sufficient. Now, children, how do we read the values? After 0, what is the next subdivision? Can you see here? How do you read the subdivision after 0? Can you say 0, 1, 2, 3, 4? No, but we don't get 5. How do you read each subdivision?
Ma'am, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on, ma'am.
Okay. Actually here they have not shown all the divisions. Let me ask you. Let me just draw and ask you. Actually, it's going to look like this on your graph paper. It's going to look like this. This is 0, or say this is 10. Okay, this is 10. Where is 15? There'll be 1, 2, 3, 4, and there'll be one middle line. Then 6, 7, 8, 9, and then this one, which is 15. Or if you look into your graph notebook, you will have these divisions between 10 and 15. If supposing you mark this as 10, there'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this one, which is 10. So, oh God. Okay, let me use this one itself. I'm just magnifying the space. Let's just take up this one. There's some space here. See here, children. The vertical line. Okay. Now this is 0. This is 0. 1 after 0. 1, 2, 3, 4, 5. Then 6, 7, 8, 9. And this one is 5. This one is marked 5. After that, 1, 2, 3, 4, 5. Okay, 6, 7, 8, 9, and then there'll be one big line, which is 10. Now, my question is, if this is 5, then what is the next division after 5? If I read 6, if I read it as 6, 5, 6, 7, 8, 9, 10 comes here, but actually 10 is here.
Ma'am, 5.1.
Let me read 5.1.
5.3.
Let me read 5.1. Somebody suggested 5.1. Okay, so it will be 5. 5.1, 5.2, 5.3, 5.4, 5. Sorry, 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9. After 5.9 is what?
10, ma'am.
After 5.9 is 10, na?
6, ma'am.
6. So we are not reaching 10. So it's wrong. We are not supposed to read like that. 5, 5.1, 5.2, 5.3 is incorrect. Yeah, 5.5. We should say 5. This is 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and 10. We should skip count in 0.5. Now, supposing we're reading between 40 and 45. Here, children, they have not shown all the 10 divisions. That's what I'm trying to say. Here, you can't see all the 10 divisions. But there will be 10 divisions, na? Between, if this is 40, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this one. So if this is if this one is 40, this one is 45. You will see so many divisions between 40 and 45. If you see your book, there will be, after 40, there will be 4 divisions and one line, one main line. And then again 4 divisions and then the main line. So how do we read? 40, 40.5, 41, 41.5, 42, 42.5. That middlemost line is 42.5, 43, 43.5, 44, 44.5, 45. So this is how we read the subdivisions between two consecutive numbers.
Ma'am?
Yeah.
Ma'am, but in the graph sheet, after 0, there is 5 only, ma'am. In between, there is only 5 lines, ma'am.
What? In your graph sheet, huh?
No, ma'am, in this second question graph sheet, ma'am. Solution graph sheet, ma'am.
Yeah, that's what I'm saying. In the graph which you see on the screen, between 0 and 5, they have shown only 5 lines.
Yes, ma'am.
But in your book, you will have 10 lines, I said. Okay, so here, I'm talking with respect to your book, not with respect to this one here. Here it is 1, 2, 3, 4, and 5.
Yes, ma'am.
No, I'm not talking with respect to this graph. In our graph notebook, you will find divisions like this.
Yes, ma'am.
Yeah.
Thank you, ma'am.
You're welcome. So how do we you know, how do we know in with what number we'll have to skip count? So what's the scale, children, we have used here? The scale is 5, right?
Yes, ma'am. Yes, ma'am.
Divide by 10 always. Always divide by 10. What is 5 by 10?
1 by 2, ma'am.
5 by 10 is 1 by 2 or 0.5.
Yes, ma'am.
That's what we did. That's why we read 5, 5.5, 6, 6.5. We kept adding 0.5 to get the value of the next consecutive division. Now coming to this one. Here also, children, see, there will be 10 divisions, meaning between two numbers, there'll be 9 divisions. Don't get confused that, see, this is that main line. Then you'll have 1, 2, 3, 4, and that midline. Then 5, 6, 7, 8, 9, and then one main line. Look into your graph notebook. So what's the scale here? 5, right? So how will you read 5, 5.5, 6, 6.57? That's how you read every subdivision. So if it is 78, you'll have to be careful. After 75, you'll get 75.5, 76, 76.5, 77, 77.5, and then 78. So you must mark the height of the bars very carefully. So please try it and then you can ask me. Remind me that we should go through the same slides in the next class. By the next class, you should have finished these graphs in your book. So only when you do it, you will realize what doubts you have.
Yes, ma'am.
Yeah. So please remind me that we have to, start from here in the next class. Okay. Just give me a minute, children. Read the question. See the table prepared alongside. I'll ask you some questions. I'll just come back. Do we understand the table, children?
Yes, ma'am.
Are we familiar?
Yes, ma'am.
Okay, are we familiar with this word or this term tally marks?
Yes, ma'am.
Okay. So how do we basically prepare this? So you need to, the different animals we have here are dog, cat, fish, rabbit, and cow. Then see here, this dog, the first one is a dog, so put a tally mark against dog. The second one is a cat, so a tally mark against cat, and then cat again. Then it is fish, then it's a cat again, then it's a rabbit, and it's a dog, then it's a cat, then it's a rabbit. So keep moving from the first one and put a tally mark against a relevant animal. That's how you build this. That's how you make the tally marks. And then a bundle of 5. This is a bundle of 5. So 5 plus 5, 10. Again here 5 plus 5, 10, 3, 4 and 1. So 28 students, a group of students, 28 students have given their have expressed their view on their, I think, favorite pet. They would like most to have as a pet, yeah, on their favorite pet. So there's the first one who said dog, the second one said cat, the third one cat again, fourth student fish, fifth student cat, sixth student rabbit, seventh student dog. So like that, there are 28 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Yes. No, I was just thinking if there are 30. 28. See, excuse me. 28 students were asked about their favorite pet. These are the answers they have given. And we have tabulated their answers in the form of a frequency distribution, where this column, the data is about pet animals. And what you see here, these numbers are called the frequencies. 10 students like to have dog as a pet. 10 other students like to have cat as a pet. 3 students like to have fish as pet. And 4 students wish to have rabbits as pets. And there's only 1 student who says would like to have a cow as a pet animal. Okay, see, cow. We'll not go into the details of English. Now, cow is not a pet animal. We know it's a domestic animal. So we're not going to all that. So this is what is the answer given by 1 student. That student wishes to have a cow. So we have tabulated the answers given by these 28 students in the form of a table. Sorry, we have tabulated them like this. We have tabulated the answers like this, where these numbers represent the frequencies. And such a table is called a frequency table or a frequency distribution table. Take a screenshot, children.
Taken, ma'am.
Although you can make a note. This one is an ungrouped frequency table. This one is an ungrouped. This one is called an ungrouped frequency table because there are no class intervals. We'll see what class intervals are. Written children, ungrouped frequency table.
Yes, ma'am.
Yeah, have a look at this one. Which is the least value? There are 60 numbers. Which is the smallest value?
50 to 60, ma'am.
Of the 60 numbers which you see in the question, which is the smallest number?
Seven, ma'am.
No. No.
Ma'am, 0.
Five, ma'am.
Ma'am, 5, ma'am, 5.
Five, ma'am.
There's nothing less than 5?
Yes, ma'am.
Okay, which is the highest value?
$50, ma'am.
The highest value is 50?
Yes, ma'am. 50, ma'am.
50, ma'am.
Yeah, looks like 50 is the highest value. Okay. So 5 is the smallest value and 50 is the highest value. So now consider the class intervals 0 to 10, 10 to 20, 20 to 30. So these are called groups, 0 to 10. We are grouping some numbers in this class interval 0 to 10. A set of numbers will fall in this group 0 to 10. So now when we say 0 to 10, 10 to 20, 20 to 30, we go up to 50 to 60. I'll tell you why. Now let's understand the values that are contained in the first class interval 0 to 10. Now 0 to 10, this is called a class interval. 10 to 20 is called a class interval. 20 to 30, class interval. 30 to 40, 40 to 50, 50 to 60. These are called class intervals. These numbers 0, 10, 20, 30, 40, 50. These are called the lower class limits. Lower class limits. Lower class limits. 0, 10, 20, 30, 40, 50 and 60. Sorry, 0, 10, 20, 30, 40 and 50 are called the lower class limits. And the other numbers 10, 20, 30, 40, 50 and 60. These numbers here are called the upper limits or upper class limits. So when you take up a class interval, just a minute, children. Yeah, children. So when you in this class interval, this is a class interval. 0 is the lower limit or lower class limit, and 10 is the upper limit or upper class limit. In 10 to 20, 10 to 20 is a class interval, where 10 is the lower class limit and 20 is the upper class limit, or simply lower limit, upper limit. You may write down the terms lower limit or lower class limit, upper limit or upper class limit. Got the terms? Lower limit or lower class limit, upper limit or upper class limit. Got it?
Yes, ma'am.
All right. So now when you consider the class interval 40 to 50, which is the upper limit?
50, ma'am.
Lower limit?
40, ma'am.
40, ma'am.
Now, does 0 belong to this class interval 0 to 10? Does 0 belong to 0 to 10?
Yes, ma'am.
1?
Yes, ma'am.
0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All these numbers belong to this class interval 0 to 10. When you take 10, see, you can see 10 and 0 to 10. You can also see 10 and 10 to 20. So there's a confusion where to include 10. Because for other numbers, you don't have a doubt. When it is 0, you're sure it is this class interval. 1, you're sure it is this. 2, 3, 4, 5, and all those numbers, no doubt. But when you have the number 10, you're not sure if you should include it in 0 to 10 or in 10 to 20. Because there's 10 here and here. Will 10 come in the class interval 10 to 20, or will 10 come in the class interval 0 to 10? So remember that the upper limit, this 10, is always a part of the lower limit of the next class interval. So when you have 10, you should always include it here in the next class interval 10 to 20, where it is the lower limit. You should see there are 10 in two places. 10 is the upper limit here, but it's a lower limit here. Wherever it is a lower limit, include it in that class interval. If a number happens in two class intervals, if a particular number happens in two class intervals, two consecutive class intervals, include it where it is the lower limit, not where it is the upper limit. So if you think I'll put 10 here, no, you shouldn't, because 10 is the upper limit, not here, not here. Here 10 is the lower limit, you should include it here. So when it's 50, 50 is the upper limit here, don't put it here. 50 is the lower limit here, so include 50 in this class interval. That is why we made the class interval 50 to 60. Because you might have wondered, why should we take 50 to 60? That's what 50 is here only, no? Why should we take 50 to 60? Because when the value is the upper limit, you should not include it in that class interval. When the value is the upper limit, it should not be included in that class interval. So that just to include the number 50, we created the class interval 50 to 60. So that 50 is a lower limit here. And 50 is included in this class interval. Will 50 be included in 40 to 50?
No, ma'am. 50 to 60.
Why not in 40 to 50?
Ma'am, because upper limit is always the part of the next lower limit, ma'am.
Correct. So just to include 50, we construct another class interval 50 to 60, where 50 is a lower limit, and you use this class interval to include 50. So 30 is here, 30 is also here. 30 should be included here and not here. Not where it is the upper limit, where it is the lower limit. Can you prepare this table, children?
Yes, ma'am. Yes, ma'am.
So we start with 0 to 10. 5 is the smallest value. Supposing 11 was the smallest value. Supposing 11 was the smallest value. Then you don't need the class interval 0 to 10. Because even if you have the class interval 0 to 10, the smallest number is 11. We won't even have one tally mark again 0 to 10. Because the smallest number is 11. The next class interval is 10 to 20. After 0 to 10, it is 10 to 20. And 11 will be included in 10 to 20. In which case, you don't need the class interval 0 to 10. We start with 0 to 10 here because there is a value 5 and there's one more value 7. 5 and 7 will be included in 0 to 10. Supposing there is no value, like the smallest value is 11, then you don't have to write the class interval 0 to 10. You can start from 10 to 20. And we stop at 50 to 60 because there's no value beyond 60. 50 to 60 because we don't have values beyond that. Is it clear, children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. So the question is, prepare a frequency distribution table for the given data. And what we have prepared is a grouped frequency table. The earlier one I said was ungrouped. This one is a grouped frequency distribution because it has class intervals. Grouped frequency distribution, grouped. Because you can make groups. In 10 to 20, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19 are grouped in the class interval 10 to 20. So since we can make small groups here, it's called a grouped frequency distribution or a grouped frequency table. Ungrouped is this one. See here, you can't make groups like 0 to 10. You can't make numerical groups like 100 to 200, 200 to 300. You cannot make such groups here. So it is ungrouped. This one is grouped because it has class intervals. So in simple words, if the frequency table or the frequency distribution table has class intervals, it's grouped. If it does not have class intervals, it's ungrouped. Can you do this, children?
Yes, ma'am.
Yes, ma'am.
No, just think about it. Will you have any doubts while doing this?
No doubts, ma'am.
Okay. Here the the number of groups you have, the number of class intervals, you should not have too many class intervals, like some 20, 25 class intervals. You should not have too many. You should not have too less also. Too less can be some 3 to 4 class intervals are too less. Supposing you have only 3 to 4 class intervals, they're too less. So 0 to 10, 10 to 20 will be an ideal way to make class intervals for this distribution. Please read the question, go through the answers, we'll discuss. Okay, now tell me the lower limit of the class interval 200 to 225.
140, ma'am.
What is the lower limit of the class interval 200 to 225?
200, ma'am.
200, ma'am.
What is the upper limit?
225, ma'am.
225.
225.
Okay. What is the upper limit of the class interval 250 to 275?
275, ma'am.
What's the lower limit of this class interval?
250, ma'am.
50, ma'am.
Ma'am, this is Kirtana, ma'am. I don't understand this sum.
Okay, no, I'm not discussing that. Okay, Kirtana.
Yes, ma'am.
What do you what do you call now? How do you read this 100 to 125, right?
Yes, ma'am.
What is that called? What is this 100 to 125 called? It is a class interval. Do you get that?
Yeah, ma'am.
Class interval. In the class interval 100 to 125, what do you call 100? In this class interval 100 to 125, what do you call 100? It's the lower class limit or simply the lower limit.
Yeah, ma'am.
And what do you call 125?
The higher limit.
No. The upper limit or the upper class limit.
Okay, ma'am.
Now tell me in 250 to 275.
250 is the lower limit and 275 is the upper limit.
Yeah, lower limit is also lower class limit. Upper limit is upper class limit. In short, we just say lower limit, upper limit.
Yes, ma'am.
Okay. So this is what is class interval, lower limit, upper limit. Now let's understand what is meant by the size of a class interval. Size of a class interval. Size of the class interval is the difference between the upper limit and the lower limit. It's a difference between the upper limit and the lower limit. So you can see the answer here, size. It's also called the width of a class interval. It's also called width. Yeah, it's also called width. Size is also called width. W-I-D-T-H. Width of a class interval. How do you do that? How do you find that? The size of the class interval or the width of a class interval? Upper class limit minus the lower class limit. So take any class interval. Take any class interval. If you choose the first one, 125 minus 100. 25 is the class size. Everywhere you can see the class size is 25. You can see it 100 to 125, 125 to 150, 150 to 175. So the class size is 25. Is that fine?
Yes, ma'am.
Yeah, look at the next one. Which class has the highest frequency?
200 to 225.
What is the highest frequency?
200.
140,
140, ma'am.
140 is the highest frequency, ma'am.
Yeah, 140 is the highest frequency. Now, 140, the highest frequency, corresponds to the class interval
200 to 225.
Yes, 200 to 225. Which class has the lowest frequency?
300 to 325, ma'am.
And what is the lowest frequency?
20, ma'am.
20.
Okay. Now, do we understand the next one? Which is the upper limit of the class interval 250 to 275?
275, ma'am.
Upper limit is 275. Lower limit?
250.
Okay. Which two classes? Classes means class intervals. Classes means class intervals. Which two classes have the same frequency?
150 to 175 and 225 to 250.
What is the highest frequency? Sorry. What was the question? Yeah, which two classes have the same frequency? What is that same frequency?
55.
55. So which are the two class intervals with the frequency 55?
150 to 175 and 225 to 250.
Very good. Any questions on this, children?
No
No,
doubts,
ma'am.
ma'am.
Okay, I hope you've taken a picture. Try this for yourself and you can see the answer also below. Take a screenshot, try this by yourself and check your table with the answer provided. So if you write 30 to 40, 40 to 50, 50 to 60, 60 to 70, you'll have only 4 class intervals. See, it is not that you should write the class intervals. There should be at least one frequency in that class interval. So supposing you start with 0 to 5. You will write 0 to 5, but there is no frequency. There is no value in that class interval 0 to 5. 5 to 10, 10 to 15, 15 to 20. There's nothing in these class intervals. So even if you write, the frequency will be 0. What is the smallest value?
131, ma'am.
131. What's the highest value?
65, ma'am.
31 and 65. The lowest observation is 31. The highest is 65. So supposing we make 30 to 40, is 31 included? 30 to 40?
Yes, ma'am.
Yes, ma'am.
Yeah, and 65 is included in 65 to 70.
Yes, ma'am.
Yeah. So I'm trying to say that even if you write the class interval 0 to 5, 5 to 10, 15 to 20, 10 to 15, 15 to 20, we don't have values that belong to those class intervals. Even if you write all of them, you will start using tally marks only from 30 to 35. So you should not write the class intervals that don't have even one value in it. Is that understood?
Yes, ma'am.
Okay. So how do you know from where to start the class intervals? You should identify the smallest and the largest value. Only then you will know from where to stop and where to stop.
Yes, ma'am.
You should identify, supposing the lowest value is 125, smallest value is 125. Why should you write 0 to 10, 10 to 20, 20 to 30 and all that? The smallest value is 125 and that will lie in the class interval 120 to 130. 120 to 130. Yes or no, children? You should not simply.
Yes, ma'am.
Supposing the smallest value is 125. Why should you write the class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40? Why? The smallest value is 125. So you should directly start with 120 to 130. 120 to 130. So there's nothing like you should start from 0 to 10. Find out the smallest value and decide the first class interval. And how do we decide the last one? Supposing the highest frequency is 207. Supposing the highest value is 207, then what will be the last class interval?
200 to 210, ma'am.
200 to 210. 200 to 210. Because 207 is the highest value. So 200 to 210. You will not write 210 to 220 because there's no value in that. There is no value that will fit into the class interval 210 to 220. So the last one will be 200 to 210. All right, children. So this one is only about making a frequency distribution. Take a screenshot and try this by yourself and check your answer. Please go through all this before you come to the next class. So take a screenshot. You don't have to work this in your book. Go through all this before you come to the next class. Or before you join the next class. This one, bars with a difference. Until here, you have to complete in your notebook. Please go through. Revise this and this. Revise this one. Take a screenshot. And this. Over, children?
Yes, ma'am.
Yes, ma'am.
All right. All right, children. So that's it for today's session. If you have any questions, please stay back. Else you may leave the meeting. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you.